So good morning. So we'll continue our discussion with the SQL queries. So today we shall discuss the next set of queries on the same relations which we saw yesterday. So it is the employee and department tables. So having these set of attributes. Okay. So here let us quickly go to the first one. Display the name of the department of the employee Bharat. So here employee name is given. So we have to get the name of the department. So name of the employee will be present in employee table. Department name will be present in department table. So we need to join those two tables. Okay, so employee and department table we will join, and then what are the conditions that we will put is the employee name should be Bharat, and the attribute that we need to extract is name of the department. So our query will be like this. So it is select the attributes we have to list over here. Select from the tables. Both the tables are required here. So employee. So let us give it an alias E, and department, let us call it as D, and where condition, first we will join these two tables on the attribute department number. So E dot D number so should be equal to D dot D number. Okay. And the other conditions include that the name of the employee should be Bharat. So and E dot name. Okay. So E dot name should be Bharat. Okay. And the attribute that we need is the name of the department. So it is D dot D name. So only this attribute is sufficient. Okay. Only department name is asked in the query. So this much is enough. So next, let us look at the other query, that is the second one. Okay. Find the youngest employee in the company. So youngest employee in the company means, so either we need age or date of birth. So here we directly have a date of birth. So we have to pick the minimum date of birth or maximum date of birth. So date of birth is a reverse concept. So maximum date we have to pick. So maximum date indicates the age is minimum. So date of birth and age are indirectly proportional, right? So if date is inversely proportional to age, okay. So if date is greater, then age will be less. So because in date comparison, it is always that the newer date is a maximum one. Okay. So based on that concept, we'll write the query for this. First thing is we have to get the date first, date of birth, and then we have to get the uh, name of that particular employee. So since it is younger, young means it is age should be maximum. So our query would be like this. Select. So we have to select the maximum of date. So maximum of DOB. So date of birth is maximum. From which table? So from employee table. Okay, so since two instances of employee table is required, so we shall call an alias as E1, and no where condition is required. So this will be our inner query where we will extract the maximum date of birth. So maximum date of birth indicates it is youngest employee. In the outer query, we have to select the name of the employee. Okay, from again employee table. So let us give it an alias E2, where here we need to put the condition. What is that condition? Where E2 dot DOB should be equal to this one. Okay. Here in place of equal to, we can also use in operator also. So whenever we have a situation like this, either we can use is equal to or we can use in operator. So both of them will work. So then count the number of male and female employees in the company. So this is one of the typical question where we are not just finding an count, but here category wise also we need whether it is a male or a female employee. So a straightforward query is not possible for this. Either we have to use the switch case, so which we discussed as part of one of our laboratory experiment, or we have to use a union operator, because two conditions we cannot put. So if we just want the count of male employees, we can get it. If we just want the count of female employees, we can get it in a single query. But both of them together, if we want, then we have to use a union operator. So what we will do is, we'll have a query like this. Select first we need to select the gender. So that is the gender type. So we should call it as gender type. And for this we have to write the uh, attribute name ourselves. So it will look like this. So select. So first we will apply it for male. So male as gender type. Okay, we are not using the variable name as gender because gender itself is one of the attribute over there. So male. So which means in the rows the data will have value male, but the header row will have this particular gender type as the column header. So along with this, we need the count. So count of star. So from which table? So again, employee table. Let us call it as E1. So what is the condition over here? So condition is E1 dot gender is equal to male. Okay. So this will get the male employees. Now verify what is written. From this particular table employee, all the rows whose value of gender is male will be filtered out. Then in the return result, its count will be returned. Along with that, we are having one more attribute, that is gender type, whose value is set to male. So our result of this particular query will look like this. So the first attribute is gender type. So another type is, yeah, here we can also rename this as count. So count. So the result will be male, and here the count value will be there like this. So this one row will be returned. Okay. So this is one way. So next is union select. Here similarly we will write female as gender type. The result is again count star as count. Okay. Then from the same table, employee E1, let us call it as E2, where E2 dot gender is equal to female. Okay. So this is another query. So now what happens after this particular query? When we perform the union operation, so one more gets added. So here the entry will be female, and the count will be here like this. So this is all the query. Again, this is one way of solving it. So another way is there. So I will um, discuss that also. Yeah. Now let us discuss one more method. So one more method is based on using the group by operator. So which means here we can group the entire employee table into two sets based on the gender, or irrespective of how many gender values are there. So for each value of gender, we can group it. Then we can extract the count of each group. That is, the aggregate functions are applied on the group itself. So this is a single query. So it will be like this. Select, okay, from, so from which table? Employee. So let us call it as E. Anyways, only one query is there. Aliasing is also not required. Where clause is also not required. We want all the employees to be in the groups. So where clause we can skip. So now we can, here we can put group by. So group by, since we have already used the alias, so we can write E dot gender. So now what happens among all the tuples present in the employee table, they will be grouped based on the gender value. Suppose if we have only male and female as the gender values, then two groups will be formed. If another category is there, others, then three groups will be formed. Now what happens? Since we have used group by, we have to extract the gender information. Here we can put the aggregate function, that is count, as alias we can also put as count. So now also um, we'll get the same result. So now our result will be like this. So gender on one side, count. So the table will be like this. Male. So what is the count? And female, the count. If suppose any other category is there in uh, any of the companies, so that will also be displayed over here. Okay. So anyway, we just need male and female. So this query also works fine. So this is based on group by operator, a very simple one. So the different ways of solving this is, one is using the union operator, another one is using group by, another one is there, that is the case operator. So that one also we can use. So again, this case one becomes complex. So the simplest one is using group by. Okay. So next, increase the salary of accounts department employees by 3%. So increasing the salary, again, you can display the increasing salary or you can update the salary. So here we'll increase the salary, which means we'll be running an update query. So the update query will be like this: update so update what we have to update, so that we need to write. So update employee, okay, set so salary. So increasing salary by 3% means it is equivalent to multiplying the current salary by 1.03. So 03 means it is 3%. So 1.3 means it is 30%. So this one is 3%. So this you need to remember. Okay. So salary will be equal to the old value of salary into 1.03. Okay. Where condition we need to write, where here the condition given it is um, accounts department. So which means, but the department name is present in the department table. So we need a mechanism to join and then find whether this particular employee is working in the accounts department or not. So once again, the comparison of the department will take place in a inner query. So since we are dealing with inner query also, so it is safer to use the alias. So let us use e1 dot salary here. Here also we'll use e1 dot salary. So here e1 dot, we have to check whether this employee works in the accounts department. So again, two ways we can do. First, we can apply the accounts department condition, extract the department number of the accounts and then equate it, or extract all the employees of the account department and check whether the employee number is there or not. So two ways we can do it, but the simplest one would be to extract the department number. So department number is equal to, here we'll select the department number. So from which table? Department table. So I will just write the short form and give it alias D. So D dot department. So I have just written DEPT because there is no space to write the complete word. So while you are writing the answer, so you have to write the complete word in the where condition, where D dot D name is equal to, so I will write out below, so accounts. Okay, so this is the query. So now what happens? Update employee set e1 dot salary is equal to e1 dot salary multiplied by 1.03. So why 1.03? So it is 1.03 means it is 3%. Okay, then where e dot department number will be equal to, select d dot department number from department table where department name is accounts. So here this portion will extract the uh, department number of the accounts department. Okay, so account department number will be extracted in this particular part and it will be equated, and only if the employee department number is equal to this, then only the salary will be incremented. Otherwise, for all other employees, this update command will not run. So if we had not written this particular where class, then salary would have been increased for all employees. All employees salary would have been increased. So due to presence of this where class, so for only those employees who meet the condition, for them only the salary will be increased. Okay. So this completes all these queries. So let us look at the next one. So which is to find the result of this particular query. Okay. So for a given relational schema for a train reservation database, find the output of the SQL query. Okay. So two tables are given: passenger, passenger ID, passenger name, age, reservation, passenger ID, class, and train ID. Okay, so the data is given over here. The query is select PID from reservation where class is equal to AC and exists select star from passenger where age greater than 65 and passenger ID is equal to reservation ID. So this is a correlated nested query because the reservation table appears in the outer query whereas the passenger appears in the inner query, and only those whose class is AC will be joined. Okay, so just look at this. So the two tables we have over here. So first condition in the reservation table that is applied is where class is equal to AC. So only those having class AC will be there. So let us remove the remaining one. So only 4 entries are there where the class is AC. Now we will work with only these 4. The other condition is select star from passenger where age is greater than 65 and then we have to join these two. Here also we must select only those passengers whose age is greater than 65. First we will remove all those who are having an age less than 65 and then we have to join these two tables. Okay. So what is the condition? Condition is age greater than 65. So we will keep only those. So first one we will not keep because here it is 65, it is greater than. So greater than means it is 66 and above. So we are left with 3 passengers, 66, 67 and 69. So 3 passengers are there. Now we have to join these two tables. Now on what attribute we have to join? So it is based on the PID we have to join. Here 1, 2, 3. Here it is 0, 1 and here it is 3. If we join, so What are the values that gets joined? So that is 1, which is common. 2 is not present over here. 3 is there. Here additional 0 is there, but 0 is not here. So the common things is 1 and 3. And hence the result of this particular query is 1 and 3. So this will be the result. Here exist operator is there, so that's why 1 and 3. So if not exists is there, then the reverse will be the answer. Okay. So this is a simple way of finding the answer. There is an alternate way actually for finding this particular answer. So that is, see, when we have exist operator, first thing is the class AC is applied, so we can remove them. Okay. Then exist operator is there. So for each attribute of for each row of this particular table, we have to execute the query, right? This is a correlated nested query. We have 4 rows over here. For each 4 rows, we have to execute this particular query. So the first row is 0. PID is having 0. For this row, find it. So PID is 0 over here. PID 0 is there here. Is the age greater than 60? The condition. So the age is not greater than 60. So this fails, because the join will not be possible. Join is possible, but age is not 36. So this row will not be able to produce any result inside this query. So inside this query, it doesn't produce any result. So if it doesn't produce any result inside this query, it indicates it will not be there in the final result. Clear? So next row, 1 AC. So 1 try to join. 1 is there. So here 1 is there. So join is possible. Next, is age greater than 65? Yes, the age when we join these two, okay, so age is greater than 65. So this row produces a result. We are not bothered about the value of the result. We are just concerned whether it will produce a result or not. Either some rows are selected or no rows are selected. So for this particular case, row is selected. So this particular row will be there in the exist part. Next, 5. PID is 5. So not possible to join. So in the join condition itself, it fails. Next, 3. 3 is there here. Is the age greater than 65? Yes, 69. So again, this row also produces a result for this underlying query. So that particular row also produces a result. So we are not here, star is there. So these two will be the intermediate results of inside. But in the outer table, we have to select only PID. So the PID of this is 1, 3. So in our result, we will have PID 1 and 3. So this is the result which we will have. Okay. So this is how you have to find the answer. So these kinds of questions will appear in uh, competitive exams also. This is one of the questions that was asked in GATE exam. Okay. So with this, we'll stop today's class and we'll continue the discussions in next class.